Hello guys, welcome to my YouTube channel. Today we will discuss about history of mobile telecommunications systems and all. So we will start from 1G. So before starting, I just want to tell you about one thing, that whenever if you guys are facing any kind of the issues, either any kind of the challenges, either having any kind of the query, you can drop a mail to me on my mail ID classes online once again e classes online once again e@gmail.com. So guys, we will start about history of mobile telecommunication system. So I will tell you that mobile telecommunication system were firstly introduced in the early 1979. Means we can say that around 40 years back approximately. As usual, you guys know that G stands for generation, that is first generation, 2G means second generation, 3G means third generation, 4G means fourth generation, and so on. What was the aim? The aim of wireless communication is to provide high quality, reliable communication, just like wired communication, like your telephone, that is home telephone. Each new generation of services represents a big step, a leap rather in that direction. Means each and every time we got a very good improvement in each technologies. This journey was actually started in the year 1979 from 1G, and it's still continuing to 5G. In India, still it's not launched 5G, but Reliance Communication told that they are about to launch, maybe, depends on them. So now we will come on we will come on 1G. That the first generation 1G system used analog communication techniques. All of you have already studied about analog and digital communication and all. Means for 1G, if you will talk about, I will show you that what was the 1G. What is the analog communication? So guys, you can see that this was our analog communication. In analog communication, the data transferred with the help of analog signal in between transmitter and receiver. Any type of the data is transferred in analog signal. Any data is converted into electric form first, and after that it's passed through communication channel. So this is our analog system, analog communication, which was followed by 1G. So in that actually the individual cells were large. I will show you the architecture of 1G also. Guys, this is the architecture of 1G. Here BTS was there, MTSO mobile telephone switching office, mobile unit, mobile station, and this one microwave or wireline. We are using on these days also this one. So in this, the individual cells were large and the system did not use the available radio spectrum efficiently. So their capability was today's standard very small. If you will compare this, then today's capability is too much high, but previously it was not too much efficient and all. So the mobile devices were large and were marketed almost exclusively at business users. The very first generation of commercial cellular network was introduced in the late 70s, means 1979 it was launched, and it was commercially used in 1980s. And it was introduced in 1987 by Telecom, known as Telstra nowadays. Australia received its first cellular mobile phone network utilizing a 1G analog system. The maximum speed of 1G is 2.4 kbps only. The maximum speed of 1G system is 2.4 kbps only. But for a better voice quality, in the last video I said it's required approximately 10 kbps. So you can guess that what was the this call quality and all. So you guys know maybe till 2018, a limited NMT services in Russia remains the only 1G cellular network still in operation till 2018. It was still was in running only. So this is the small confirmation regarding 1G. For 2G, we will discuss in detail today. In last video, I shown you about that how our call flow will go from mobile equipment. Without SIM, our mobile will be mobile equipment, and with SIM, it will be as a mobile station. So now, and you guys may be aware that 2G is working as a on digital communication. You can check here. Digital communication is the physical transfer of data over point to point or point to multi-point communication channel, which are used by some internet service provider also nowadays itself. It is transfer of discrete messages. Digital communication plays a vital role in today's electronic world. In digital communication, the data transfer rate depends upon its characteristics. So the main difference between 1G and 2G was that 1G was using analog while 2G was using digital communication. Main motive of this generation was to provide secure and reliable communication channel. It implemented the concept of CDMA. CDMA is also the 2G, like 2G GSM technology only. It's provided the small data service like SMS and MMS, means short messaging services and multimedia servicing. 2G cellular telecom networks were commercially launched on the GSM standard in Finland by Radiolinja. Radiolinja. In 1991. So it was launched in 1991. 2G capabilities are achieved by allowing multiple users on a single channel via multiplexing during 2G cellular phones are used for data also along with voice. Initially, it was using for only and only call services, not for data. But later, after enhancing, it was supposed to use data and call both. And after that, it was support instant messaging services like SMS. The most popular 2G system was the Global System for Mobile Communication, means GSM. This is GSM technology, which was designed as a pan-European technology, but which later became popular throughout the world. The property name of IS-95 is CDMA1. IS-95 is a terminology which is used in 3GPP, world standard, and that was the CDMA technology. It is a 2G mobile telecommunication standard that uses CDMA. Three primary benefits of 2G networks over their predecessor was: first one, digitally encrypted phone conversation, at least between the mobile phone and the cellular base station, means it was digitally encrypted, means no I can say that it was a little bit secure for, but at least between from the mobile station, means your mobile, and till to base station, means BTS, base transfer system. But in the rest of the network, it was not necessary. Later, use of the radio frequency spectrum, enabling more users per frequency band. Means at a single time many users can be connect. There is no problem. And third one was data service for mobile starting with SMS text messages. Means you can use the voice, data, either SMS at the same time. There is no problem. It was after enhancing the technologies in 2G only, later than we was able to start all that. Initially, 2G provides a speed of 13.8 kbps, which was without internet. Just understand my point. Initially, 2G provides the speed of 13.8 kbps, which was without internet. The maximum speed of 2G with GPRS, means General Packet Radio Services, means with internet, is 40 kbps. That is after enhancing. With as means enhanced data rates for GSM evolution, means as GSM, there is a theoretical maximum transfer speed of 384 kbps was about to receive. The success of 2G communication system came at the same time as the early growth of the internet. Means as slowly internet growth started, so 2G communication was also started growing and all. It was natural for network operators to bring their concepts together by allowing users to download data onto mobile devices. To do this so-called 2.5G system, but on the original ideas from 2G, by introducing the core network packet switch domain and by modifying the air interface so that it could handle data as well as voice. Means in 2G it was normal. As I had already shown you the architecture, I will show you the architecture once again, guys. This is the 2G architecture, which I had shown you in the last video also. And I explained each and everything about call and all, how it will work, how it will not work. So initially it was the architecture for 2G and later 2.5G and 2.75G also came in the picture. So why? Because it was required because of in 2G initially there was that was launched for only and only for call quality and all. Later with call in 2.5G with call data SMS conference call and many more things was added in the 2.5G in 2G itself, and in 2.5G data speed was data was added along with your calls and messages as well. And after that 2.75 we have received around 384 kbps speed also in 2G only. But as per this one the requirement of the data day by day, so much and more data speed was about to get by the users. So this was the requirement. So then 3G came in the picture in the year 2000. 3G operators has to maintain two core network. One thing I was forget to tell you about one thing, that in this on 2G we will use only and only circuit switching, not packet switching. Means that will work only and only circuit switching, not not on packet switching. But 3G operators has to maintain two core networks. Means the circuit switch domains for voice and the packet switch domains for data. Means circuit switching and packet switching both was introduced in this. So this generation set the standards for the most of the wireless technology. We have came to know web browsing, email, video downloading, picture sharing, and other smartphone technology were introduced in third generation. Maximum, many of the guys you will be aware that while 3G was launched, internet was started, and we can start internet surfing on our mobile itself. We can access internet, we can download the videos, we can share the pictures and many another things with the help of our smartphones. So in the year 2000 it was launched, and it was launched commercially in the year 2001, but that is different scenario that in India it was launched around 2012, I think so. 3G is the Universal Mobile Telecommunication System, means UMTS. UMTS was developed from GSM by completely changing the technology used on the air interface while keeping the core network almost unchanged. Means in core network, one thing was added, that is packet switching. The system was later enhanced for data application by introducing the 3.5G technologies of high-speed downlink packet access (HSDPA). High-speed downlink packet access means high-speed data we require. That's why, and high-speed uplink packet access (HSUPA), which are collectively known as high-speed packet access. Means if we will merge HSDPA and HSUPA, it will be commonly known as HSPA, high-speed packet access. The UMTS air interface has two slightly different implementations. Wideband code division multiple access (WCDMA) is the version that was originally specified, and that one is currently used through most of the world. And another one, time division synchronized code division multiple access (TD-SCDMA) means time division synchronous code division multiple access. It is a derivative of WCDMA, wireless code division multiple access, which is also known as the low chip rate option of UMTS TDD mode. In a related issue, 3G network introduced delays of the order of 100 milliseconds. So now we are moving that why 4G was required. Why 4G was required. So we are coming on that picture. Like 2G, 3G evolved into 3.5G and 3.75G as more features were introduced in order to bring about 4G. But newer generation of phones are practically always designed to be backward compatible. So a 4G phone can communicate through a 3G or even 2G network. Means whenever if your new phone will be introduced, definitely our old network cannot be avoided. It means our new mobile should work with old network also. So that's why it was designed like that only, with support for both CS circuit switching and PS packet switching. Both 3G onwards data demand increased. 3G onwards data demand increased. Entire wireless services are divided into two parts, that is real time and non-real time. That is real time services and non-real time services. Real time services means, suppose if you are attending any class and there is a packet drop issues, then there is no mean of that particular class. And suppose if you are streaming any video, there delay can be possible, but packet drop cannot be possible. So in the same scenario, if you are downloading the movie, video streaming, this content will be same. Suppose on Skype call is going on, but there is packet drops, then there is no use of call. Some services can be delayed, but loss of packet can't be tolerated. Just understand this point. Some services can be delayed, but loss of packet can't be tolerated. Same way, in some services, loss of packets can be tolerated, but delay cannot be tolerated. Like our video call, either we can say either any Skype call, I can say either something, any calls like video call, I can say. So now we will talk about some protocols and all. 3G having RLC layer, MAC layer, physical layer, RRC layer, NAS layer. We will discuss in this further. Now this radio protocol is completely changed compared to 2G and 3G. But core network protocol of 2G and 3G is not that much changed. Because of 3G core network, if protocol is same, then architecture will also be same. So 3G core network is using the same architecture as our GSM. Hence, whenever any new evolution will be there, different mobile will be required with capable chipset. Existing chipset will never support for any new revolution. Means suppose if you are having a 2G handset, definitely it will not support for 3G and 4G also, either for 5G also. This is the reason in 3G core network protocol has no any changes. Radio protocol has changed. Has changes. Why LT required? We will understand this point by this particular diagram. Guys, you can understand this point. This is the total monthly mobile voice and data traffic as measured by Ericsson. Here you can see this. This is in petabyte per month. In petabyte, you can check that what is the minimum and maximum this denomination of our digit denomination of byte. This will be started from byte and kilobyte, megabyte, and gigabyte. Like this, it will be come in petabyte, and last is zettabyte something. So see, this is blue colored. This is voice call. This is voice, and this is the huge demand of data. See, it's cost 9,000 petabyte. This is the trend for a month only. This is the trend for a month. That is worldwide only. See, quarter 1, 2, 3, 4. See, this is the particular data and voice comparison. So because of this particular thing, we introduced 4G. For many years, voice calls dominated the traffic in mobile telecommunication network. The growth of mobile data was initially slow. Mobile data growth was initially really slow, but in the years up to 2010, its use started to increase dramatically. Since the year 2010, in this the data uses was increased dramatically till June 2013. Worldwide mobile telecommunication network utilization was approximately 1,500 petabyte. This data captured by Ericsson Mobility Report. In this letter, voice call was minimal comparison than data. This was monthly traffic data. In the same way, from 2013 to 2018, voice call traffic was approximately 150 petabyte to 180 petabyte only, while data traffic was increased from 1000 petabyte to 6500 petabytes per month for whole world. And introduction of the Apple iPhone in 2007, maybe many guys you will be aware that Apple iPhone was launched in the year 2007, followed by devices based on Google's Android operating system from 2008. Android launched in 2008 by Google and all. So these smartphones were more attractive and user-friendly than their predecessors and were designed to support the creation of application by third party. Means on our mobiles we can access, nowadays we can access any kind of the third party, especially in our Android mobiles. We can use third party like WhatsApp, Facebook, and other many another kind of the application we can utilize in easy way. So in the same, the result was an exploration in the number of use of mobile application. Other than this, operator provided the flat data rate charging scheme which permitted unlimited data downloads. That's lead to a situation where neither developers nor users were motivated to limit their data consumption. Nowadays, I don't think so that any of the person is not using 1 GB per day. But what was the scenario? Just 2-3 years back only, for 2 GB, we were using this particular data for data of 2 GB for whole month. But now there is no value of data and all. So that's why. So guys, on this today's video, I explained about what was the use and why 4G required. So in this next video, we will discuss about 4G requirement and 4G long-term evolution and many more things and many protocol level things we will discuss. Thank you.